Hi everyone, this is Mrs. Leong, and we will be starting Chapter 5 with Lesson 1, Operations with Polynomials. So this chapter we're going to be doing a lot with polynomials, and so we need to know our exponent rules. So here are the properties of exponents we're going to need, and we'll just quickly run through these. When we have a product of power, so we've got the same base and we're multiplying, we want to add those exponents, all right, and we keep that same base. If we have a power to the power, we multiply those exponents, keeping that same base. When we have a product taken to an exponent, we can give each factor that exponent. However, please do not mistake this to mean that a plus b to the m power is equal to a to the m plus b to the m. This is not true, so make sure you do not mistake that product here to also apply to sums or differences. All right, negative exponents, you can make sure to have a positive one by taking the reciprocal. And when we have a quotient and they're dividing, you want to subtract the exponents. And similar to this one, when you have a ratio, you can give the numerator an exponent and the denominator the exponent. All right, and then lastly, anything to the 0 power is equal to 1 except for 0 itself. All right, so those are some properties you want to be able to use to simplify. So let's go and practice that. Starting with number 1, I'm going to be using that first property. Since I have the same base and I'm multiplying, I can just go ahead and add that 12 plus -4 plus 6, keeping that same base of c, and that gets me c to the 14th. All right. Number 2, I can go ahead and subtract the exponent, so that's just b to the 6th power. All right, and number 3, since I have a power to a power, I can multiply 4 and 5 to get a to the 20th. All right, number 4, I have multiple bases here, so go ahead and combine those bases. I'm going to have x to the power of -2 minus 4, and then y, this is y to the first here, will be 1 minus -1. So this gets me x to the -6 and y to the +2. And for this to be fully simplified, make sure you have no negative exponents. So to make that 6 a positive, I bring it down to the denominator. All right, and that's number 4. Number 5, different ways you can do this. I would actually handle that -1 exponent first by flipping that entire fraction inside. So I don't need to worry about it. All right. And then now I can do the same thing I did with number 4. So I got -3 minus 2 for my a, and then 2 minus 1 for my b, giving me a to the -5, b to the first. To make that a positive, I'm going to make that b over a to the 5th. Final answer. All right, number 6. Okay, different ways you can do this. I would actually reduce the inside first, since I can get that to be x over y squared. And then go ahead and give the numerator an exponent and the denominator the exponent, multiplying that 2 and 2. And there you go. If you did it the other way, where you actually gave each factor the exponent first and then subtracted, you would end up with the same answer anyway. So either way. All right, number 7 will be the last one I'll show, and then I want you guys to practice some. So for number 7, I'll go ahead and simplify each parenthesis first, giving each factor the exponent. All right, so then this whole thing squared gets me this. And then the second parenthesis giving each factor that exponent of 2. All right, so the coefficient I have is 25 over 2. And then I can go ahead and add the 4 and the 2 exponent to get base a to the power of 6. Base b will be power of 8. And then c doesn't get multiplied with anything, so it just stays the same. All right, so go ahead and practice some of these properties yourselves. Try number 8 through 12. Pause the video and then try 8 through 12, and then unpause to see the answers. All right, so here are the answers for numbers 8 through 12. Number 8 was m to the 15th. Number 9 was 2m squared over n. Number 10 was just 2. Number 11 was negative 12j squared over k to the 5th. And 12 was 3m squared over 2. All right, let's get into some terminology. Okay, so we have this thing called a monomial versus a polynomial. And using this prefix of mono versus poly, you can probably guess that a monomial is a single term. So it's either a number, a variable, or an expression that's a product of one or more variables with non-negative integer exponents. All right, so whenever it's like just a product, it's still the same term. All right, a polynomial is a finite sum of terms in which all variables have whole number exponents and no variable appears in the denominator. All right, so let's go ahead and use those rules to determine whether the expression is a polynomial. If so, state the degree of the polynomial. I'll explain what that is. Okay, so for number 2, I'll take a look at this, and I see that I do have multiple terms, all right? But it is a finite sum of terms in which all variables have whole number exponents. So this is a polynomial. So yes, polynomial. All right, and the degree of this polynomial will be a degree of 2. It is the highest exponent if you look at all the degrees of each term. All right, so this term has degree of 2, this has degree of 1, this has degree of 0. All right, so it's that highest one. So this is degree 2. All right, number 14. Number 14 is not a polynomial because we have variables that appear in the denominator. So not a polynomial. Okay, it doesn't tell us to justify, but just for yourself if you want, I'm going to say since variables are in the denominator. All right, cool. Let's flip to the back and simplify some of these polynomials. All right, here we go. Just a bunch of combining like terms here. I have these like terms. Keep in mind I'm subtracting here, so make sure you are subtracting. So you got x, or I guess just to be safe, maybe we should just distribute that. Negative. You don't have to, but I know people tend to make careless mistakes when it comes to negative, so maybe it's just a little safer. So 2x squared. This one combines to minus 4x. This one combines to 5. All right, and I'm going to stop here. Now, some people might be tempted to try to factor that. Don't even try. It says simplify, not factor, and we're not trying to solve for when that equals to 0, so factoring doesn't help. When you simplify, you want to get rid of parentheses, right? So you don't want to create parentheses. So please don't try to factor, and know the difference between the directions of simplifying and factoring. All right, number 16. All right, so similarly, all right, this is plus, so I don't have to worry so much about careless mistakes, but I can combine some like terms here. I got my y squared term, so that's 3y squared. I have my xy term, so 18xy, and then I have my x squared term, so minus 8x squared. In terms of the order, we typically like to do like highest degree alphabetical, but if you left it like that, I would be okay. Okay, but technically, this is the appropriate order. All right, number 17. Ooh, a bunch of fractions. All right. So for this one, I'm going to go ahead and combine what I can see. I got my x squared term and my x squared term. Get that common denominator. This is going to be 2 over 8. So that's going to be negative 1/8 x squared. I have my xy term and xy term, common denominator. Gets me negative 4 over 8, so that would be a minus 7 over 8 xy. And my y squared term, common denominator, that'll be 2 over 4. So plus 3 over 4 y squared. All right, that's my final answer for that. Okay, number 18. Okay, so number 18, again, combining like terms. You guys get the idea now. 9p cubed, p squared gets me negative 2p squared. And then 3 negative 7p's gets me negative 4p. Again, it is factorable. I could take out that p, but I'm trying to simplify. I'm not trying to factor. Okay, number 19. Let's go ahead and multiply. Here, we'll distribute. That gets me 6x cubed minus 10x. Done. Number 20. Distribute. That will get you 42a minus 14a squared, minus 7a cubed. And let's just reorder that around from highest degree to lowest degree. All right, number 21. So number 21, I'm going to FOIL this out. Gets me x to the fourth minus 5x squared minus 2x squared plus 10. Combine your middle two like terms, you get x to the fourth minus 7x to the second plus 10. All right, and number 22. Go ahead and distribute. That gets me x cubed minus 3x squared plus 4x. Distribute. And for this one, instead of putting it on the side next to that, 4x right here, I'm going to go ahead and stack it. It'll just be a little bit easier to combine like terms. So I'm going to put it underneath here so that my x squared terms align, plus 3x minus 4. And you can go ahead and add those together. And it's just a little bit easier to combine like terms, seeing them up and down like that. All right, so a little trick there. All right, let's try our last one, number 23. The area of the base of a rectangular box measures that many square units. The height of the box measures x units. Find a polynomial expression for the volume of the box. All right, so basically we have this box, and we know that the area of this base right here is that polynomial, and the height of the box is x. All right, so the volume is just going to be that height times the area of the base. So that's going to be 2x cubed plus 4x squared minus 3x. And because it's a word problem, I do want to put units, so I'm going to put units cubed since I don't know what the units are. All right, and that is it for lesson 1.